signposting the incompleteness of our current theories of these extreme scales and energies and demanding a more fundamental, unified description of nature. The concept of a singularity, where known physical laws and even the fabric of space-time are predicted to dissolve or become undefinable, presents an intriguing, though not identical, conceptual parallel to the Buddhist notion of sunyata. While sunyata is a philosophical assertion about the emptiness of all phenomena concerning inherent, fixed characteristics or an independent nature, a physical singularity represents a state where fundamental physical properties like density and curvature become infinite, and spacetime itself loses its conventional, definable structure. Both concepts, in their respective domains, point towards a breakdown of conventional, easily categorizable descriptions and hint at an underlying reality that defies straightforward characterization within standard frameworks. If a future theory of quantum gravity indeed resolves classical singularities, demonstrating that they are not points of actual infinite density but rather some other exotic quantum state, this state would still be profoundly different from anything described by classical physics, perhaps resonating with the idea of emptiness as a realm of pure potentiality or a state beyond conventional attributes. B. Causality as the genesis. The Big Bang singularity. The Big Bang cosmological model, in its classical formulation based on general relativity, posits an initial singularity at time t equals 0, representing the presumed beginning of the universe, space, and time itself. This initial state is characterized by infinite density and temperature. Such a starting point poses a fundamental challenge to the classical understanding of causality, which typically assumes that every effect must have a cause that precedes it in time. If time itself originates at the Big Bang singularity, the question, what caused the Big Bang, becomes deeply problematic, as there is no before in which a classical cause could exist. Some cosmological analyses describe the Big Bang singularity in terms of the incompleteness of an extendable causal, i.e., non-spacelike path-directed curves, meaning that causal chains cannot be traced back beyond this point. This breakdown of classical, temporally ordered causality at the universe's origin necessitates the exploration of alternative causal models. This is not merely a philosophical exercise but a requirement driven by the limitations inherent in physical theory when confronted with such an extreme boundary condition. To speak of a cause for the Big Bang, one must either abandon the principle of causality for this unique event or redefine causality in a manner that does not strictly rely on temporal priority. Speculations in this area include the idea of simultaneous or transcendent causation. For instance, philosopher William Lane Craig, engaging with the arguments of Adolf Grunbaum, suggests that the cause of the universe's origin could have acted coincidentally at